Hello everyone, and welcome to the lesson on area and volume ratio. So when we're doing problems like this, the figures are similar, all right? So you've got two geometric shapes and they're similar, so sides are proportional, okay? So in general, there's a ratio from side, area would be side squared. Volume would be side cubed, okay? So the ratio of the sides, okay? All right, that's the ratio theorem. So let's take a look at the first problem. You have two figures, and their sides are in the ratio of 4 to 17. So their areas is squared now, right? So their areas will be in the ratio of 4 squared, or 16, to 17 squared, or 289. So that's the ratio of the areas if the sides are 4 to 17. So now if the ratio of the volumes is 216 to 512, going backwards from volume to side, it's the cube root, right? So you have the cube root of 216. And that would be compared to the cube root of 512. And that is a 6 to 8 ratio. Okay? So now, if the areas are in a ratio, what's the ratio of the volumes? Well, so to get from area back to your original dimension, you have to take the square root. So you have the square root of 49 and the square root of 121. So 7 to 11 is the ratio of the sides. Now you've got to go, okay, those are the side ratios. Now you have to go 7 cubed to 11 cubed, and that will be 343 to 1331. Let me fix that. That's a little messy. It's 343 to 1331. Okay? So you have to manipulate this. So area square units, you have to go back to regular units, then you have to cube it to go back to volume. Now on D, the volumes are in the ratio of 729 to 1,000. So cube root of 729 and the cube root of 1,000. All right, which makes it 9 to 10. That's the area of the sides. Now that's the ratio of the sides, excuse me. Now to get surface area, you have to square those. So 9 squared is 81 and 10 squared is 100. So you start out with the ratio of the volumes, 729 to 1,000. You had to bring it back to the ratio of the sides, which is 9 to 10. Then you had to square that to get the ratio of the areas, okay? So if we take a look at E, now that's interesting. The area of the ratios. The area ratio is 256 to 361. And we got to think back, and we did problems like that with similarity. The perimeter ratio is the same as the ratio of the sides. So this is worded a little interesting, a little tricky. So what you've got to do is this. Take the square root of 256 and the square root of 361. That will give you the ratio of the sides, which is also the ratio of the perimeters. Okay, so you wind up with 16 to 19. So part F, the side ratio is 13 to 14. Well, the volumes is going to be 13 cubed to 14 cubed, or 2,000 197 to 2,744. So these are calculated problems, okay? Cube root, you have to find it on the calculator. It's a math function, okay? You know what a square root is? So you've got to remember, they're talking about sides to area, you're going to square it. Volume, to bring it back to original dimension, you have to take the cube root. All right? So you've got to look at this. That's your dimension. That's the area. And that's the volume. Okay? So, this is the lesson on area and volume ratios. And this lesson was brought directly to you from my dining room table.